Okay, so we have a velocity time graph here, and we are asked to calculate the acceleration. The acceleration from a velocity time graph is equal to the gradient. All right, but because this is a curve, as the question says, we are first asked to draw a tangent. So tangent is a straight line that just grazes the graph at the point that you are interested in, so at that 20-second mark. You then find the gradient, because the gradient is the change in the y divided by the change in the x. So my change in y is 40, 60 minus 20, and my change in x is 36. That gives me a value of 1.11 meters per second squared. To get the full 4 marks, you have to have a value in the range of 1.05 to 1.15 meters squared. However, if you have anything in the region between 1.0 and 1.2 meters per second squared, as long as you have shown clearly how you found it, that will score you 3 marks. Okay, now we're asked to determine the distance travelled by the car during the first 80 seconds of its journey. So this is quite a lot of marks available here for your precision in actually finding this value. But the first thing you need to identify that when you have a velocity time graph, the distance is the area underneath that graph. So you now need to annotate your graph really clearly. There are a couple of ways you can either do this. You can either use the trapezium method. So you can divide it into trapeziums and calculate the area of each of those and add them up. Or you can divide it into rectangles and triangles and work out the individual areas of those. Or you can use the counting squares method. Now you can see here I've done the counting squares method. So what happens is you work out the total area of one square. Now I've just used the large square here, and that was 20 by 20, which gives a total area of 400 meters for a single large square. When you then count up how many squares you've actually got, you then say, well, okay, if, for example, there are about 9 squares here, then you take 9 squares, each at 400 meters, giving us a total of 3,600 meters. Now, actually, having done this on here, mine is not the most accurate. So there's a range of values here that you can score between to get the full marks. So if you have between 3,200 and 4,200, that will get you 3 marks. If you have 3,500 up to 4,000, that will get you 4 marks. And in order to get the full 5, you need to have a value in the range of 3,700 to 3,800. So when you are counting squares, make sure that you are accurate in terms of identifying how many squares you've actually got. Now, finally, we are asked to explain the motion of the car after 80 seconds. Now, if we look at what the graph is doing after 80 seconds, we can see we have a straight horizontal line. Now, a straight horizontal line on a velocity time graph means that the velocity is constant. So that's identifying initially what the velocity is actually doing. But we are now being asked to explain that. So what is it that must be happening to mean that the velocity of that must be constant? So when we think about objects moving with a constant velocity, we have to now consider the forces that are acting on them. So if we think about the forces acting on this car moving forward, there would be a driving force sending it forward, and there would be air resistance acting against it. However, if there is velocity that is constant, that means there will be no acceleration. And for there to be no acceleration, we need to have balanced forces. So we have to get in here the idea that the driving force must therefore be equal to the air resistance acting against it. And therefore, if those two forces are balanced, we know that the resultant force is 0.